Very good morning, students. Today I'll continue from Unit 1 of Machine for Class 10. In the previous video, I have shown you some topics from Unit 1. Today I'll continue with the remaining topics of Unit 1 as far as possible. So, as far as today's topic is concerned, today I'll be teaching you about the two types of machine, that is ideal machine and perfect machine. Ideal machine or perfect machine and practical machine. What is the difference between these two? So, as far as machine is concerned, machine can be divided into two types. One is your ideal or perfect machine, and another one is your practical machine. As far as ideal or perfect machine is concerned, every company, whenever they make a machine, they keep in mind that whatsoever energy is spent in a machine, same amount of output work the machine will give to the user. But practically speaking, this doesn't happen. This doesn't happen. Means 100% input work is not equal to 100% output work. So if any machine on giving 100% input work gives you 100% output work, then that machine is an ideal or perfect machine. But this doesn't happen. Practical machine is that machine which we use in our everyday life, where 100% input work is not equal to 100% output work. But every company, whenever they make a machine, they keep in mind that as far as possible 100% input work should be equal to 100% output work. Now obviously here a question will arise that if a company makes a machine keeping in mind that 100% input work should be equal to 100% output work, then why doesn't it happen? It doesn't happen because of certain reasons. The reason is whatever energy is given in the machine, some of the energy is lost in overcoming friction between the different machinery parts of a machine. And since some amount of energy is lost in overcoming the frictional forces or resistive forces, thereafter 100% input work is not equal to 100% output work. But keeping in mind the concept of ideal or perfect machine, every company, as I told you, keeps in mind that they are going to make a machine where 100% input work on a machine will be equal to 100% output work. So the principle of a machine, the company, whenever they make a machine, they keep in mind a principle for a particular machine. And what is the principle of a machine? The principle of a machine is input work should be always equal to output work. But does it work? It doesn't work in this manner. They keep in mind this principle and try to make a machine which is ideal or perfect, but in our day-to-day life we don't get this result where input work is equal to output work, because there are some frictional forces which has to be overcome by a machine, and thereafter some amount of energy is lost. That is why whatever machine we use, that is not ideal or perfect machine, but that is a practical machine. Now that is all about your machine, the two types of machine, the principle of a machine. Now we'll come to the derivation of relationship between efficiency, mechanical advantage and velocity ratio. These three technical terms, efficiency, mechanical advantage and velocity ratio, I have discussed in my previous video. So I am going to derive the relationship between them. So the next topic is derivation of the relationship between efficiency. I am using the symbols for these technical terms. This is the symbol of efficiency, mechanical advantage and velocity ratio. MA means mechanical advantage, VR means velocity ratio, and this symbol which resembles like N with a tail ending, this is known as eta. It is a symbol of efficiency. So let us derive the relationship between mechanical advantage, efficiency and velocity ratio. In my previous video, I told you that efficiency is nothing but it is the ratio of output work divided by input work. I also told you that output work means what load the machine has lifted and to what displacement, how much displacement has the machine covered with that particular load. So output work is nothing but, as you know, that work means force into displacement. So in case of output work, the force will be load, and the displacement is nothing but the displacement of load. Symbolically, displacement of load I have written as small d suffix L, and load is denoted by capital L. As far as input work is concerned, it is nothing but how much force you have given on the machine in order to get an answer. Means in order to get an output work. So the force that you have given on the machine is nothing but the effort. Obviously there will be displacement of the effort, and the displacement of the effort I am showing with small letter d suffix capital E. This is the symbol of displacement of effort. Now over here I do some mathematical maneuvers. Load by effort. Instead of multiplication sign I am writing here a division sign, and I am writing a displacement of effort by displacement of load. I am just shuffling it over because I have given here division sign. In my previous video I already told you that the ratio between load and effort is known as mechanical advantage, and the ratio of displacement of effort and displacement of load is known as velocity ratio. So we come to the relationship finally that efficiency is nothing but the ratio of mechanical advantage and velocity ratio. Efficiency is nothing but the ratio of mechanical advantage and velocity ratio. But this is the relationship that I have derived, but you must keep in mind some points. Some note below points I am writing here. Once again I am mentioning this topic is for class 10, unit 1, physics, and this is a continuation of my previous video. So right now I am going to tell you about some points which you must remember or which you must take away from this relationship. Just now you got that efficiency is equal to mechanical advantage by velocity ratio. I explained it just now. Now, as far as practical machine is concerned, for practical machines, efficiency is always less than 100%. Efficiency is always less than 100%. Now, if a question arises in your mind that why it is less than 100%, I have already explained it here that why it will be less than 100%. Once again, I am telling you that efficiency for practical machine will be less than 100%. I have used the symbol less than because in such machine some amount of energy will be wasted in overcoming the frictional forces between the machinery parts of the machine. Thereafter, the efficiency will always be less than 100%, means the input work in such practical machine will always be more than the output work. Means the output work will always be less than the input work. Input work greater than output work. In other way, output work will be less than input work. Now, since efficiency is less than 100% for practical machines, it means mechanical advantage for such practical machine is always less than velocity ratio. I've used the symbol less then mechanical advantage is always less than velocity ratio for such practical machines. For perfect machines, if at all such machines are invented in near future, then for perfect machines we know that input work is always equal to output work, and therefore the efficiency will always be 100%. If efficiency is always 100% for such a perfect machine or ideal machine, then in that case mechanical advantage will always be equal to velocity ratio. So this was regarding machine, the different parts of the different types of machine, ideal or perfect machine, practical machine. Then principle of machine, which I told you that every company wants to keep in mind this principle, that whatever will be the input work, same will be the output work, but in real life it doesn't happen, because in our everyday life we encounter machines which are practical, where the input work is more than the output work, because some amount of energy is wasted in overcoming the frictional forces between the different parts of a machine. Then I told you about the derivation of the relationship between efficiency, mechanical advantage and velocity ratio. And after deriving, I told you that you must take away some points from this relationship. And these points are this. The first point is, we know that efficiency is equal to mechanical advantage by velocity ratio. For practical machines, efficiency is less than 100%. Therefore, mechanical advantage will be less than velocity ratio. But for perfect machine, efficiency is equal to 100%, because for perfect machine, input work and output work are same. Therefore, mechanical advantage and velocity ratio will be same. Now, I'll move on to the next topic, and the next topic is lever. As far as lever is concerned, it is a straight, rigid means strong enough, tough, bar means a rod. It is a straight, rigid bar capable of bending around a fixed point known as fulcrum. It is a straight, the key words straight, rigid means strong enough, bar means a rod, capable of bending around a fixed point, means it will have the tendency of bending around a fixed point, and that fixed point is known as fulcrum. For example, this I'm having with me this pen. If I try to balance it on my fingertip on a particular position, wherever it will get balanced, and it will have a tendency of bending around that particular point of my finger, then that point where I balance this pen, that point happens to be the fulcrum, because around that point the two ends of this pen will try to bend, either on the left hand side or on the right hand side. So this is lever all about. Let me draw the schematic diagram of a lever. This is the lever, a straight rigid bar. I told you that it will have a tendency of bending around a fixed point. That fixed point around which it will bend, it is known as fulcrum. I have fixed this particular lever on a knife edge, on a pointed surface known as knife edge, and that point around which this particular lever will bend, that is known as fulcrum. On the two ends, I'll apply two forces. On one end, I'll apply load, and on the another end, I'll apply another force, that is effort. The distance between, the perpendicular distance between load and fulcrum, it is known as load arm. I repeat, the perpendicular distance between load and fulcrum is known as load arm, and the perpendicular distance between effort and fulcrum is known as effort arm. Okay, this was about liver. Now, in my next video, I'll tell you about the different types of liver. I'll try to differentiate between the three different types of liver. As of now, concentrate on the two videos that I have given. Study them, go through them. In case you have any problem, give me a call. So at last, I would simply like to tell you that amidst this pandemic, widespread of this COVID-19 pandemic, please stay healthy, stay home. But last but not the least, I would like to applaud the COVID warriors. They are doing a wonderful job for us. So hats off for all the COVID warriors in my state and all around India. Signing off, Jai Hind.